Okay, so the next problem in the lead code we are solving is combinations. Okay, basically here we have given the n is equal to 4 and n and k value. Let's see like what does it mean and what are the expectation here. Okay, so basically we have been given a n is equal to 4 and n k is equal to 2. What does it n is equal to 4 meaning? We have this one. Okay, like I mean list of numbers starting from 1 to 4. Okay, so this is n means what is k here? We need to build a combinations out of it. And what is the length of the combination? Like if there are not, combination is nothing but like arranging things here and there, right? Let's say that if there is no length, like I mean we could arrange, like what are the possible ways that we could arrange this one, correct? So it can be shuffled in any, in number of ways, right? Like I mean too many number of ways. Okay, so yeah, that is it. Like I mean the k defines the size of it, like what is the combination size. Currently it is 4, you need to reduce it to 2, and we'll have to build a different combinations. Okay, that's what it means. So for this given thing, n is equal to 4, k is equal to 2, these are the possible combination for here, correct? We can build it like 1 2 1 3 1 4, and similarly 2 3 2 4, right? And finally 3 4, right? These are the possible combination that can be built, correct? So now similarly when is n is equal to 4 and k is equal to 3, what we can, what will be the combination? 1 2 3 and 1 2 4, correct? And the next 2 in here also. Let me pick a new color for this one. And whenever here it can be 2 3 4, nothing else. Like I mean as a k is equal to 3, this is the last combination. We cannot try from 2, like we cannot try from 3, because we are will be overflowing it. We can do 3 4, but it will not have anything next to it, correct? So now, okay, this is the problem about. Now let's see that how we can approach this problem, right? So basically what is happening here, we are trying to like I mean build a path here basically, right? Like I mean we're trying the combination here. It looks like this, right? See, like we are going to 1 2 3 and we are coming back and we are trying the different combinations here. Let's say that if there is one more number 5, right, we'll again come back, we'll try it, we'll come back, try it. So right, like I mean what we're basically doing here is like kind of traversing it, right? Like kind of building a path. So let's say that I'm going, want to go here, I have a different paths to go, correct? I can go from, I can jump it, like I can go to 1, I can go to jump to 2, I can finally jump to 5, or I can do it either way around, correct? It's like building a path. And also to keep it simpler, right, like whenever we are trying to build a combinations like this, right, like go for and come back and try different things and all these things, it's nothing but a backtracking, correct? So backtracking, what does it mean? Like we will have a start point here and we will go to end point, correct? You will need to find that path there. So there will be different condition here. It might be like end node, okay, like we will be checking for a condition. Or else it can be like something like you'll go here and there was something else that was blocking you, you will come back and you will try again, and there was some other blocking, you will come back trying again, right? This is what the backtracking algorithm, and it will have some ending condition, correct? End condition it will be there. And also you will rely on the previous path, right? Like whenever once you have the blockage, you will come back and you will try to do something. You might be finding the solution, you might have found the solution already, but you might be finding the efficient one, so you will come back and you will try these things here, right? So backtracking is the way to go. Like I mean currently we are trying to build a combination, right? We'll be using a backtracking algorithm here. So backtracking is nothing but a recursion, right? We will be building a recursive solution here, and to build a different combinations here. Combinations, we can simply call it as a paths here. Okay, so now what we are going to do, like, and as we said, right, whenever we want to build a backtracking, we need to rely on the previous paths, like what has been built so far already. We are going to use that to build a new path. Okay, and also here you can see, one second. Also here you can see, like whenever you start, right, like what we are going to do, like initial approach, like without all this programming stuff, right? What we are going to do, we are going to pick this one first element, correct? First element we are going to pick it. And so now if you want to apply the combination, we are left with this one, correct? Yeah, that is it. So what's happening here is, what this is the decision that we are making. So whichever that available node, right, we are going to however we are going to pick all the nodes, right? We have to go, we're going to try all the combination 1 2 3 4, right? That simply indicates that we can need to use a for loop here, right? We need to use a for loop and we'll be checking the combination for each. Like I mean initially we have built the initial path, like using the for loop, what we can do is we can build the initial path 1 2 3 and 4. Okay, that will be like kind of this one. Okay, initial path will be this one, 1 2 3 and 4. We have it is straightforward, right? Like I mean using the for loop, we are trying to use a backtracking and we need an initial path here to build the next path, correct? So to build the path, basically we'll have can iterate through it and building the path. Okay, so once we are done with this one, let's say that we are done with one, right? What we are going to do, like what we are like whatever the possible next combination, the next possible list is this one, right? Whatever the index of it will be, whatever that is left, we are going to build the combinations out of it, correct? So whenever we are trying to build a path here, so we'll iterate through this for loop. So we have got the initial path, and what we are going to do here is like whatever the combination that number next comes, right, we're going to add it to the old path, Okay, we'll get to know this more clear when we implement it. Okay, so this will be 1 2 3 4. Okay, so now, okay, so now, like, I mean, currently what we are going to do is, we'll be, every time we got a list, right, we'll be having a n number of combination to do. So we will just iterate through the for loop. Okay, we'll be running the for loop to get the different combinations here, correct? And whatever the combination that we build, we'll add it to the old path. Okay, now let's quickly check the code actually, so that it will be clear. So basically what we'll do is, we'll assume that we have not built any combinations, and start index also as a 0. What does it mean is, um, so let's say that we have built this index. Okay, let me clear this again. So let's say that whenever you don't, if you don't start it yet, so it will, you will be here, correct? Like, you will be having all these number of choice, so you can try out combination for everything. So as we build 1 2 3 4, like start node can all of this. So once you pick this one, right, you are left with only 2 3 4, whatever the index next to it, that is the that you are left. Once you pick the 2 also, you are left with only 3 4, right? So this is what is happening there currently. What we are happening is, so initially we'll send it as 0, like, okay, that will be your start index. Okay, so far we have not built anything, so I will call it as a so far, we'll be sending it as so far. Okay, and once we want to build a list now, right? So far is we have not built anything. We'll iterate to the for loop and we'll add everything to it. Okay, for time being, you can just consider it as a I. Actually, like, here it's a one based index, right? That's why it is I plus 1. You can ignore it for now, simply consider it as I for now. Okay, so currently what we are trying to do is, we are trying to build a path. So far there was nothing. Whatever the path that we are going to build, we are going to add it to it. Okay, we are going to add it to it, we are going to send it to the child node. So we're telling the child recursion function that have built the function, build this path so far here, you keep adding to this. Okay, that's what it looks like. So once we build this path, we need to tell, what does the child recursive function do. It can access only this part, right? Like, once we are done with one, once we are done with one, it can access only from 2 3 4, correct? Once we are done with this, we can access only to this. So we'll have to update our index, so that it can try the combination only for 2 3 4. Okay, this is it. So ultimately, when we are trying to build a combination, if the length is equal to the final node k, right? Like, I mean, this is our backtracking. So let's say that we, in the kinds of building a path, like, I mean, if you are going from source to destination, we will be checking if the end node is met or not. If it is met, like, I mean, we'll be adding that to the result, correct? So here, that's what we are doing. Let's say global variable, we have declared it as a global, and wherever we have found that length, any combination of length k, we'll add it to the result, we'll simply return it. Okay, and we need to make sure that we will have a common return type. Like, we cannot return one boolean once here, and we can list and with single value. We need to make sure we should be consistent about that throughout the recursive function. Okay, and we have declared it as a none. So everywhere we go, we should make sure that we return the same thing, so that we don't mess up anywhere. Actually, even if we return anything here, we're not catching it, so it doesn't make sense. But yeah, it's just that we'll be returning a none here. Okay, so to summarize here, what we are going to do here is, here we are talking about building a combination. Whenever it is a combination problem, it's nothing but a backtracking we need to do, right, to generate a new combinations. And backtracking is nothing but a recursion here, right? So we are here now. Okay, we are here. And also, to build a combination, we need to know, like, I mean, for a backtracking path, you need to rely on the previous paths, like, I mean, what has been built so far, right? So we'll be sending it as an empty initially, and we'll be starting the recursion, building the path from 0. So we'll be iterating through all this to start building a path. So first we'll start building for 1. Okay, once you build for 1, you will ask the child recursion to build for the new nodes. Okay, so it will be like going for a sub arrays again and again. Once it is done 1, it will go to the 2. It will send a 2 3 for 3 4 to the child, and child recursion, it will build a combination out of it and send it back to the, ultimately it is building the path. Ultimately, when it reaches to the length, we'll be returning it back, like, I mean, result is done. So it's like, it works like this actually, to simplify. We'll be trying the combinations like one here, right? Here, if we talk about this, I will be building 2. Okay, and I will go in building 3. So I will coming back here once, okay, length is met. So we'll be adding this to the result. I will be coming back to the 2, and I will be adding this to the 4. Next, adding to that 4. So this is done, this is done. So I cannot do anything much. So in the first, we'll come back to the first parent iteration. So there we are done with 1. So now next we'll go to the 2. So 2 comma 3. Okay, and then we'll come back to the 4. So again, it will come back and try to go to the here, but it is not there. We'll come exit back, and we cannot. We'll do the same for 3 and 4, but we don't get any result. We'll not add it back to the result there. So that is it. Yeah. Thanks.